Okay, so we are going to look at operations on functions today. The first operations we're going to look at is adding and subtracting. We've done this with polynomials, adding and subtracting. We haven't seen it with this notation. So remember that notation, function notation, is f of x and g of x. So when you see f of x plus g of x, that means add the two functions. Another way to write that is actually to write it as f minus g of x, because they have to have the same variable to combine them anyways. So you can see it in one parentheses or separated, and it means the same thing. So here's our first example. We're going to add, here we go. Let's let f of x equal 5 square root x and g of x equal negative 8 square root x. So in the homework, you're going to have to find f plus g of x and f minus g of x. And so we have 5 square root x plus negative 8 square root x. And we learned earlier in the chapter that when we're adding and subtracting, the radicals have to have the same index and the same radicand, and square root x and square root x are the same. So now we just subtract the numbers in front. 5 minus 8 is negative 3 square root x. And if we're doing f minus g of x, 5 square root x minus negative 8 square root x, we actually are going to end up adding, because minus a negative becomes plus a positive, and that is 13 square root x. And then it says state the domain. So the domain for all these functions, x square root functions, x must be greater than or equal to 0. X has to be greater than or equal to 0. You'll find that by setting whatever's under the radical, x minus h, right? We set that part greater than or equal to 0 and solve if there's something else going on under there. And then what is f of 16? Or find, evaluate the sum, it says, evaluate the sum when x equals 16. So that the sum is negative 3 square root of x, which will be 16. So negative 3 times 4, negative 12. Let's do an example with a polynomial. Let's say we have f of x equals x squared minus 4, and g of x equals 3x squared plus 4x minus 2. So to find f plus g of x, we're going to add x squared plus 4 to 3x squared plus 4x minus 2. We'll combine up our like terms. There's our x's, so 4, or x squared, so 4x squared plus 4x, and 4 minus 2 is plus 2. And then f minus g of x is going to be x squared plus 4 minus the parentheses 3x squared plus 4x minus 2. Now remember that that minus applies to all three terms in there. So that's going to become negative 3x squared minus 4x and plus 2. So we get negative 2x squared, because x squared minus 3x squared minus 4x, and 4 plus 2 is plus 6. And the domain for an x squared function is all real numbers. And then find the value when x is equal to 2 of the sum. So that's 4 times 2 squared plus 4 times 2 plus 2. So 4 times 4, remember you have to do your exponent first, plus 8 plus 2, 16, plus 8 plus 2 gives me 26. Okay, next we're going to talk about multiplying and dividing. So let's let f of x equal x cubed. And let's g of x equal the square root of x. So we're going to find f times g of x, f g of x, that's f times g, or f of x times g of x. So that is x cubed times the square root of x, which is x cubed square root x. Can't really do anything more with that. My domain is x has to be greater than or equal to 0. And let's evaluate this when it equals 4. So it says evaluate when x equals 4. So that's 4 cubed times the square root of 4, which is 64 times 2, 128. Now let's say we have to divide f divided by g of x. This is f of x divided by g of x. That's what it means. So we have x cubed divided by the square root of x. To do that, we're going to multiply by the square root of x on the top and the bottom so that we can rationalize the denominator. Then we get x cubed square root of x, and then x squared times x squared is the square root of x. I'm sorry, square root of x times square root of x is the square root of x squared, which is x. And then this x here on the bottom cancels one of these, so we get x squared square root x. That's the division. So it's stuff we've been doing, it's just different notation. F g of x means times, f over x is divide, and we just divide the two functions. The next thing we're going to do is composites. Composites is something we've actually done when we've been doing our transformation work, but the notation is a little bit different. Notation is like, so remember when we did f of x minus 4 as a horizontal translation to the right 4, and let's say our function was the square root of 2x plus 4 minus 3. Let's erase a little bit of that. And we had to plug this in. We had to plug this part in to the x here so that we could distribute it. And so we did the square root of 2 and then x minus 4. Then the rest of the function is plus 4 minus 3. So we are plugging this part into that function. So it's something we've done, but the notation is going to be a little different. Instead, it's going to say let f of x equal the square root of 2x plus 4. Always make that too long, minus 3. And let g of x equals x minus 4. Find f of g of x. This is pronounced f of g of x, which means to plug g into the function f, which is what we did here. So again, it's going to be the same thing. The x minus 4 goes in for that x, and we simplify. So we end up with the square root of 2, and then x minus 4, and then the minus plus 4 minus 3. So the square root of 2x minus 8 plus 4, and the square root of 2x minus 4 minus 3. This would be f of g of x. Now, another way they write the notation is with an open circle. So this could also be written like f circle g, and it's an open circle, not a closed dot like multiplication, and then the x on the outside, and it means the same thing, to plug g into f. And we always work from the inside out, which means we can also go the other way around. Find g of f of x. This is g of f of x. Oops. Or it can be written like g of f of x, which means plug g, oops, it's not g, it's plug f into the function g. And you could go on and on with several functions to do this as well. So let's go back to what we had before. We had f of x was the square root of 2x plus 4 minus 3, and g of x was x minus 4. So to find g of f of x, or g of f of x, same thing, different notation, would mean I'm taking this and I'm going to put it in for x here. So I have, let me get my pen, the square root of 2x plus 4 minus 3 minus 4. And so then the only thing I can do is combine my constants. So I have the square root of 2x plus 4 minus 7. So that is composites. Let's do a couple more examples. Let's let f of x equal x squared plus 5, and let g of x equal x minus 2. So first we're going to find f of g of x. And so we're going to take x minus 2 and plug it into f. So f is x squared, right? That's x squared plus 5. And now we're going to take x minus 2 and put it in for that. So we have x minus 2 squared plus 5. When we have x minus 2 squared, we need to multiply that out. So negative 4, negative 2x, negative 2x and x squared. That's x squared minus 4x minus 4. So that's x squared minus 4x minus 4 plus 5, which is x squared minus 4x plus 1. And now we'll find g of f of x. And that means I'm going to take x minus 2, and I'm going to plug in x squared plus 5. And that's just basically x squared plus 3. Now, sometimes it doesn't have a variable, so what it wants you to do is find a value. So we're going to say that let's let f of x equal 3x minus 2, and let g of x equal 2x squared, and let's let h of x equal 2x to the 2/3 power. And it's going to say find, let's see, f of g of h of x. Nope, not of x. We're doing ones with not x's. F of g of h of 8. So it wants me to plug 8 in. Okay, and the other way this could be written is f of g of h of 8. 1, 2, 3 sets of parentheses. So this means we're going to start on the inside out. So we're going to start with the h of 8. And we're going to find that. It's easier to plug the number in and then get that than it is to work the other way around. So, or finding the equation and then plugging the number in. So we're going to find h of 8, which is 2 times 8 to the 2/3 power. And 8 to the 2/3 power is the cube root of 8 squared. The cube root of 8 is 2. 2 squared is 4. And now we'll times that by 2, which gives us 8 back again. So that was h of 8. So now I have f of g of 8 because I already did the h of 8 part. And now I'm going to plug 8 into g. G is 2x squared. And then I'm going to take that. That's 2 times 64, which is 128. Now I have g of 8, which is 128. So we're going to now do f of 128. And that gives me 3 times 128 minus 2. So that's 24 plus 60, which is 84, right? I'm doing 128 times 3. So I'm doing 8 times 3 is 24. And 20 times 3 is 60. So that gives me 84 plus 3 times 100, 300. That's 384 minus 2. And so that's 382. So f of g of h of 8 equals 382. Let's do another one. Okay, let's find, maybe go the other way around. Pause it or rewind it if you needed to copy that more. Okay, so let's find g of f of negative 3. So that means when it's written this way, that means g of f of negative 3. So we're going to start by finding f of negative 3, which is 3 times negative 3 minus 2. Negative 9 minus 2 is negative 11. And so now we're finding g of negative 11, which is 2 times 11 squared, negative 11 squared, 2 times positive 121, which is 242. So g of f of negative 3 equals 242. So we can go lots of ways, we can go lots of numbers, we can do lots of different functions. And the name is just to reference which function you're going to plug it in. You always work from the inside out if it's in the parentheses notation. If it's in the composite notation with the little circle, you start with the number closest to the x and the or number. Okay, let's do one more example. Let's find maybe g of h of x. So remember that means I'm going to start with h of x and I'm going to plug it into g. So g is 2x squared, and then I'm going to plug h into that, 2x to the 2/3 power. And so remember, when it's in parentheses and it has an exponent on the outside here, this square is going to apply to the 2 because it's in the parentheses. So that's 2 times 4, and then 2/3 times 2, x to the 4/3 power, and then 8x to the 4/3 power. Okay, and then if we were to evaluate that, when x equals 27, how about 8 times 27 to the 4/3, which is 8 times the cube root of 27 to the 4th, which is 8 times 3 to the 4th, which is 8 times 81, which is 648.